Okay, in this session, I wanted to talk about how do we sketch basic parabolas. Okay, so let's get started. Okay, so we can see that we have y is equal to 2x squared plus 4, and for number 2 we have y is equal to negative 3x squared minus 2. Now these two graphs, they follow this format: y is equal to x squared plus q. And one very important thing that you need to know when it comes to sketching of these graphs is that we only need two bits of information to sketch these graphs. Okay, so the first bit of information that we need the coordinates of the turning point, and then the second information is that we need the coordinates of the x-intercept. Okay, if we know the coordinates of the turning point and we know the coordinates of the x-intercept, then we can simply sketch the graph, because we will consider the sign of a, and we can use that to figure out the shape of our graph. Okay, so let's begin. Let us begin. Now, for number one, let's determine the x-intercept first. Okay, so remember, to determine the x-intercept, you have to let y be equal to 0. Okay, if we do that, we will have 0 equal to 2x squared plus 4. Okay, and then we can factorize the right hand side. So if I take out 2, I'm left with x squared plus 2. And then I divide by 2 on both sides, I will be left with 0 is equal to x squared plus 2. Okay, now let's try and isolate x squared and see what happens. If 2 goes to the other side, it will become minus 2. Now we have a situation, we have a bit of a problem, because we know that whatever value that you insert for x, there's no way that x squared can produce a negative number. Okay, so this is an indication that we have no x-intercept for this our graph, because it produces a it produces a situation that is not possible. Okay, so it's a good sign that we do not have x-intercept. So we can say that therefore there are no x-intercept. Okay, there are no x our graph does not have any x-intercept. Okay, so, and this makes perfect sense, because if we think about this situation, we we can see that for y is equal to 2x squared, basically it's the graph that looks like this, remember, with the turning point being 0, 0. But then if I take this graph and add 4 to it, then it means that this graph will be shifted 4 units upwards. So therefore, it will look something of this sort. And it is crystal clear that this pink graph is not touching the x-axis. Okay, so this is the reason why we ended up with this kind of situation, whereby we have an ambiguous scenario at the end of our equation here, because this is not possible. Then this is an indication that there are no x-intercept. Okay, so that is the case. And now let's work out the turning point of our graph. Okay, so the turning point, remember that for these graphs, y is equal to x squared plus q, the turning point is always 0 and the q value. That is always the coordinate of our turning point. So turning point The coordinates of the turning point is given by x is equal to 0 and y is equal to q, and q is positive 4 in this situation. Okay, so now we can sketch our graph. Okay, so 1, 2, 3, 4. So we have a point here. That is our turning point. And then we can go on and sketch our graph. So it can look something like that. Something like this. So this is y is equal to 2x squared plus 2x squared plus 4. Okay, and we can label our axes. So this is the y-axis, and then this is the x-axis. Okay, so this is the sketch of number 1. Okay, so now let's consider number 2. Okay, so let's work on number 2. Okay, now if we consider this situation, let's try and determine the x-intercept. Okay, so the x-intercept of this equation, we will obtain that if we let y to be equal to 0. Okay, and then if this is the situation, then we have 0 is equal to negative 3x squared minus 2. Okay, and then what can happen is that we can divide everything by negative 1, and then if we do that, we see that we end up with 3x squared plus 2. Okay, and then when we end up with 3x squared plus 2, I take the 2 to the other side, it becomes minus 2, and then I am left with this situation. And then if I divide both sides by 3, I have negative 2 over 3, which is equal to positive x squared. Now, this is similar to the previous case. Okay, we can see that we have a situation whereby x squared is equal to negative 2 over 3, and this can never be the case. Okay, so this is another instance whereby we do not have x-intercept. Okay, so they are no, okay, they are no x-intercept. Okay, so there are no x-intercept. And then if we determine the coordinates of the turning point, we know that the turning point is always given by x is equal to 0, y is equal to p. Now, the y is equal to q, I mean, the q value is minus 2. Okay, so these are the coordinates of the turning point. Now, we can sketch this graph. Okay, we can sketch this graph. Okay, and then okay, now we see that the graph is negative 3x squared, so it has this kind of scenario. So the turning point is at x is 0, y is minus 2, so it is somewhere minus 1, minus 2, somewhere here. and then the graph is negative 3x squared minus 2, so it will be a sad face, so it will look something like that. Okay, like that. Okay, so this is basically how our graph will look. And then the coordinates of our point, the turning point, is x is equal to 0 and y is equal to minus 2. So we can just put minus 2 over there, and then we can label our axes. Okay, so this is the y-axis, and then this is the x-axis. Okay, and then we can label our graph that this is the graph whereby y is equal to negative 3x squared minus 2. Okay, now let's do another example whereby they are actually y in x-intercept. Okay, so let's say we have what y is equal to 2x squared minus, let's say, minus 4. Okay, so for this one, let's determine the x-intercept. Okay, so the x-intercept, to determine this, we must let y to be equal to 0. Okay, and then if this is the case, then we can do that. You can say 2x squared minus 4 is equal to 0, and then we can factorize the right hand side to take out 2. We will be left with x squared minus 2. Okay, and then dividing by 2 on both sides, we will have what? 0 is equal to x squared minus 2. Okay, now we can factorize the right hand side further. Okay, so we see that we will have this kind of situation. So it will be negative, and then there's a positive, and then we have x, we have root 2, and then we have root 2 like that. Okay, and then we can see that the results of this equation will be x is equal to positive root 2, or x is equal to negative root 2. Okay, so these are the x coordinates of this graph. Y is equal to 2x squared minus 4. Now let's determine the turning point. The turning point is very simple to determine in this our case, because we know that the turning point is x is equal to 0, y is equal to q. Okay, so it is 0 minus 4 like that. Now we are ready to sketch our graph. Okay, so let's get it done. Okay, so we have a situation like that. Situation like that. This is our y-axis, and then this is our x, and then the coordinates of the turning point is 0 and minus 4. So minus 1, minus 2, minus 3, and minus 4. So it will be there. Okay, and then the coordinates of the x-intercept, they are at root 2 and minus root 2. So root 2 is around 1.4. Okay, so it's approximately equal to 1.4. So if I say this is positive root 2, then negative root 2 will be somewhere over there. Okay, so if I say this is negative root 2, then this will be positive root 2, and then this is minus 4. So I can draw my graph. And noting the fact that the a value is positive, then I know that my graph will look like a happy face. Okay, so it will be something of this sort. Go up like that, and then we'll go up like this as well. So this is, it's not a smooth curve, but you get the idea. Okay, so this is y is equal to 2x squared minus 4. Okay, so this is how our graph would look like.